In this video, we are going to talk about Arduino Uno. When I say Arduino Uno, we are going to talk about the hardware that is being used here. So we will be talking about the components that are available and the ports that are available here for interacting with this board. So let's get started with the most important component that is present here. So that is the black dual package stuff that is present here. So this is this IC, or like integrated circuit we call them as. So this is called the microcontroller, and specifically this is a Atmel microcontroller at Atmel Mega 328P, and that is what is present in Arduino Uno R3, the revised version 3. So this is where everything happens, all the computations happen. And this is, you can call it as the brain or heart of the device. And these devices are called microcontrollers. And often when we talk about computers, like we talk about microprocessors. So what's the difference between a microprocessor and like a microcontroller? So microprocessors have a central processing unit, and that central processing unit has to be connected to like a RAM, a random access memory. So which is a memory like that is really fast, having a really fast read-write speeds. Like that means you can like do billions of read-write operations in a second. So you can do that actually. So we need some storage like that to do some computations. Let's say if you're adding two numbers, like say we need to hold those numbers somewhere, and we need to do the operation, and we need to have a space or a memory to hold the reminders or like the carry during those calculations. And for all those things we need somewhere like somewhere we can easily access them. So that is called the random access memory. So we have that, and we also have a storage, so typically your hard drive. Now we use something called SSD, solid state drive, where you don't have any moving parts. So you have all these things as a separate component actually. But the difference between a microprocessor and a microcontroller is like the microprocessor just processes information. So you might have heard about a 2-core processor and 8-core processor and things like that. So what this processor does is, like say you will have pins, you just feed it some information, say what kind of computation, or like you give it an instruction what it has to do, and then it'll do that, and like it'll spit out the results. And you will have to handle everything else. So what information I send to the processor, and like what comes back, I need to store that. Like you will have to take care of all those things. In a microcontroller, everything is kind of packaged together. So the program, which is the instruction, is present in the same chip, and the RAM, or the registers in this case, is present in the same chip. So everything is kind of like combined together. So that is an advantage. You don't have to have like multiple chips to have something working. But there's a disadvantage too. So microprocessors are used like where you need a lot of computation power, and you can like really customize everything, and that is possible. But like in microcontrollers, you don't have that. It'll be like say it'll have like very less storage. You can't write like say megabytes and megabytes of information. So that megabytes of when I say information, I'm talking about instructions for the computer to run. So you can't do that. Like say there are some limitations here. But again, for a simple task, like say for operating a microwave or something like that, this information, or like say this storage is like more than enough. And that is why we use a microcontroller here. And so let's talk about other components. And again, the most important component here is the microcontroller. So Arduino is powered by DC power. So you have two ports. You have a USB port. as you may know, like say we charge our phones through USB port. Now we have USB-C, and it has a power channel which will carry power and charge our phones. And exactly the same principle, you can use the USB to power the Arduino board as well. But if you wanted this to independently operate, like say we use the USB port to program them as well. And we use something called, say, USART. We'll talk about that in a while. Say that is, we also call them serial communication. Pretty much every communication that we use these days are serial communication. But when we say serial communication, we specifically talk about universal, synchronous, asynchronous receiver transmitter. So RxTX, these pins, we'll talk about these later. But again, this is how we program our microcontrollers, and we will also be talking with the Arduino board through RxTX as well. So we use the USB port for communication as well. So apart from this IC, we have another chip that has a program to convert the serial communication into USB protocol actually. So the protocols will be varying. So it converts USB protocol. It's again the way we send information and how fast we send those information, and things like that would change. You might have heard of HDMI, USB, USB-C, and then probably display ports, mini display, lightning cable, and say all those things. Pretty much everything uses is called serial communication. But the most important thing is everything has a protocol, and they might send information at different speeds, and so that is what a protocol means actually. So here again, we have another chip that converts from USB to serial communication, and that happens. And we use that port for communicating or writing programs and communicating with the Arduino Uno board as well. And we also have, say, some power pins. So now the power is available to the board through either these power ports and USB. And again, maybe we didn't talk about power ports much. So once we program this through them, so we don't need the USB port for programming anymore, because I've programmed my board already. Now I wanted this to work independently. So let's say I can connect a battery through the power port, and then let it have this running. So let's say I'm building a data logger which wants to log the temperature information for years maybe. So I will connect a battery, and then I don't need to connect it to a computer and say collect all those information. Instead, I will probably connect a SD card or something, and then I can write all those things and use as a data logger. So in that case, I don't need to connect it through a USB port. I would just connect a power plug and then have it running for years. So that is the power port. And then so since the board has access to power, now we can also draw power from this board. Say for some of the applications what we use, we don't need that much power. So for those, we will not use any external power. We will just draw power from these pins. So we have a 5 volt and 3.3 volts. So those are the standard voltages we use. We don't use any voltage higher than those actually. So that is what we have. And now let's talk about the pins. These pins are called IO pins, or input output pins. We have some analog pins, and these are, if you see here, it is just mentioned analog in, which means it is just input, you can just input analog. And here we have something called digital pins, and these digital pins can be either configured as input or output. So you can use this to read some digital information to see whether something is turned on or not, or you can use this pin to turn on something actually. So you can do either of those. And we also have something called pulse width modulation, so which is a way of providing analog output. But it is not technically analog. So when we say analog, it is continuous. So let's say the output analog voltage, you can feed any voltage between 0 and 5 volts. So it can be 0.1 volts, 0.2 or 0.5 volts. So it can be any voltage. It's like continuous number between, like, say 0 and 5. So it can be any number in between. But in pulse width modulation, what we do is we vary the duty cycle. So we just like change the output is going to be the maximum or zero. So it's either going to be 5 volts or 0 volts. You can't provide an output of 0.05 volts or like something like that, or 0.5 volts or something like that. So we can change the duty cycle, which means like how often it is turned on in a second. Let's say in a second, if you turn on that pin for like 50% of the time and turn it off for 50% of the time, then we call it a 50% duty cycle, which means the output is like kind of half of like the usual. So we can use something like that. So that's what is indicated here. It's called pulse width modulation. You can provide kind of an analog voltage using pulse width modulation, but again, that is not like analog, a real analog. Like, it's not going to be continuous. It's going to be just like on-off indication. So that is pulse width modulation. So these are the pins like which we will be often using. So the I/O pins. And let's go to the next slide. And we also have other pins which you can use it for communication. So we talked about USART. That is like the RxTX pins. This is used for communication. Likewise, there are other communication protocols like I2C and SPI. So these are like very basic level communications that we use for connecting, say, ICs and say connecting some other components. So these devices, like say USB ports and like USB protocol and like say HDMI, these protocols are like really advanced protocols, and you can't use those protocols to communicate between say two ICs maybe. So in that case, like you need to communicate in like a very simple protocol like I2C or SPI. So you can also use some of these pins to pins for that communication, but we would not read about those much in this course. But we will be using USART, RxTX pins for communicating. So in this course, we'll be calling those serial communication. So this is the hardware. So I hope you're comfortable with that. And I believe by now you would have connected your board with the computer. And I believe like you happen to download Arduino IDE, and then like you connected those and checked whether you were able to speak with that. Actually, so I hope that has happened, because I would have or like I have uploaded the videos for like say checking this connection already. So I hope you would have tried that, and now we are good to go to the next submodule, like which is Arduino IDE. So see you in the next submodule.